It was like gonna be in 7th grade when I kept asking.
Not necessary.
Too much drag.
And you don't shut up over there.
Too much drag.
But you're up for me.
Where's my phone?
Alright, guys.
I'm not out. Wait, weren't you the one
Hush,
that
let's take
notes?
notes. We should take notes.
Oh, but I never thought I'd hear you say that in my
Guys,
life.
if I
You
told
just
you
want to get to the running
He told us to take notes.
I just want to get class.
Hey guys.
You didn't want to.
I hope we have beat you today, but probably not.
We probably don't have to.
Well, I don't even know if we get dressed out.
I don't want to do that. I don't want to do that.
If we do have
Hey, you little.
You don't have your shirt?
No, I can't find it.
Why can't this be the
Half the bar is chewed up shirt.
Like,
It's too
Are we ready to start now?
yes.
Okay. So we're on exponential decay now. So this will look very similar to what we were doing yesterday. It's just the graphs are going to be, instead of going up like they were yesterday, they're going to be like falling. So it'll look more like this. Still doesn't cross the x-axis. Just drops and goes down. The formula that we had yesterday for like the word problems, the word problem like would be the same. It would just, you'd end up with, well, it would be a little different for decay rate. We're not going to actually use that, so I'm not going to put it up here. The only one is like the interest one that I want you to know how to do. So, jumping into some problems, because there's not really a whole lot since we did most of the notes for this stuff yesterday. It's pretty much the same for decay. So, these ones just say to graph the function. They still say identify the domain and range. Domain and range is still the same. Domain is still all real numbers, and the range, or sorry, yeah. And the range is from 0 to infinity, just like it was for growth. Nothing is changing on that front, so just leave that there. So number 8, y equals 1 over 6 raised to the x. So notice these ones are fractions now, compared to yesterday. They were like either a positive or negative number basically, that was bigger than 1. But b is between 0 and 1, meaning it's going to be a fraction or potentially a decimal. So we're going to do the table the same way we did yesterday. So I'm going to leave the little spot to do the math in. Again, it's up to you if you want to do it in the table or out of the table. I'm still going to use -1, 0, and 1 for the most part, just like we were doing with that. So nothing too crazy here. Probably won't do as many examples unless we feel like we need it. But all right, so I've got 1/6 raised to the, and notice that's everything in that parentheses raised to the -1. So that tells me if I have a fraction and it's raised to a negative, I'm going to flip the stuff over. And so this is going to become 6 to the 1 or just 6. 0, I have 1/6 raised to the 0, which is 1. And then I've got 1/6 raised to the 1, which just stays 1/6. So then I can set up my graph. So at -1, I'm up at 6. At 0, I'm at 1. And at 1, I'm at 1/6, so just a little bit above. And then we just connect and come down. Not crossing the axis there. So really not a significant difference other than that you're dealing with fractions. But even yesterday we had an occasional fraction here and there, right? Because when we had the negative, it was flipping our whole number into a fraction. So not anything too crazy. These aren't meant to be super hard. Let's see. 12. Y equals 3 over 5 raised to the x. So set up the table same way. So this time I've got 3/5 raised to the -1, which would be what? Yep, 5/3. And then 3/5 raised to the 0 is 1, and 3/5 raised to the 1 is, yep, 3/5. Now, 5/3 is approximately what? It's a little less than 2. It would be about 1 2/3. Okay, so it's a little less than 2. So that means I'm going to go up to 2 on my y-axis, right? I don't need to go up farther than that for the sake of the problems that we're doing. So at -1, I'm up just a little bit under 2. At 0, it's at 1. And at 1, it's at 3/5, which is a little over half. So this one's not getting steep as quickly, or at least it doesn't look like it. But we still draw it the same way. It's still curved around. Now, just to talk about it so you've seen it, if something like this happens, number 18, y equals 0.25 raised to the x. Now, that decimals, as far as being raised to like a negative power, it's going to be a little bit harder. But what is 0.25 as a fraction? 1/4. So I would treat this as 1/4 raised to the x if I was going to work with this problem, and then I would go from there. So then, setting up my table, I would just use 1/4 to solve this. So 1/4 raised to the -1 would be what? 4. 1/4 raised to the 0 is
1.
And then 1/4 to the 1, which obviously we don't really need to write that one, right? Because we know it's going to be just whatever it is, but if you want to write it out, you can. So then graphing this one, I need to go up to 4 on the y. So at -1, I'm up at 4. At 0, I'm at 1. And at 1, I'm at 1/4, so just a little bit above there. And then just connecting like that. All right, so the next ones, yesterday when we did them, there was like a number times 3 to the x. This one is going to be something times 1/4 to the x. So basically, we've just done 1/4 to the x. So we'll kind of be looking at it comparatively, and we're not actually doing the compare part, but that'll be kind of what the next ones are. So we're just going to do a couple of them as far as this goes with that. So let's see. 20. Y equals 5 times 1/4 raised to the x. All right, so I've got 5 times 1/4 raised to the -1, So the 1/4 raised to the -1 would be what?
So 4 times 5.
Yep, so this would end up being 5 times 4, which is 20. Obviously, pretty big number there. 5 times 1/4 raised to the 0.
5.
Just be 5. So it'd be 5 times 1. And then 5 times 1/4 raised to the 1.
5 over 4.
It's just 5 over 4. So a little bit bigger than 1, right? So what I would do, obviously this number is up to 20. I don't think we had any that were quite that big yesterday. I'm going to count by 5s on my y-axis so that I'm not doing 20 little tick marks all the way up. If you want to do that, that's fine, but making it a little easier here. So I'm going to count by 5s. And I'm going to make sure that I'm noting somewhere that I'm counting by 5s, because otherwise I'm going to think you just don't know how to graph. So at -1, I'm at 20. At 0, I'm at 5. And then at 1, I'm at 5/4, so that's a little bit above 1. But in the scheme of, like, relativity, I guess, to the graph, it's still pretty close to the axis. And then just coming down and connecting. All right, I'm going to jump, and then we're going to come back. So these numbers are going to be out of order, but you'll see why in just a second. So 26, y equals -5 times 1/4 raised to the x. What's different about this problem than the last one?
Negative.
Negative, but the numbers are the same, right?
Yeah.
So, yep, it's going to flip it upside down. So mathematically, the numbers are the same as up here. Everything's just going to be multiplied by a negative instead. So I've got -5 times 1/4 to the -1, which is going to end up being a -20. At 0, I've got -5 times 1/4 raised to the 0, which is -5. And then at 1, I've got -5 times 1/4 raised to the 1, which is -5/4. So the numbers were exactly the same. So I didn't really need to do the math again. I just needed to show that they were negative now just because of them being multiplied by -5 instead of +5. So now my graph is going to be flipped upside down, so it's going to be on the bottom. So I'm going to, again, I'm going to count by 5s, but going down in the negative direction. So at -1, I'm down at -20. At 0, I'm at -5. And at 1, I'm at -5/4. So this one is like it's going up. So if you look, I should have drawn them a little bit closer. But these are mirror images of each other. Okay? Just flipped upside down. Mirrored upside down, not sideways like a normal mirror. They have their Snapchat camera on.
Wait, what?
This.
You guys are too busy talking to pay attention.
Well, she was asking me a question. I was answering it, so I didn't.
I said they're mirrored, but not like a normal mirror. But I was saying it's like a Snapchat camera because it's backwards.
We're not allowed to have Snapchat in my house.
Don't ask me
I don't
more
have
questions.
Snapchat or really any media.
I didn't have it till 10th grade, so.
I'm not allowed to have
I
it.
can't.
I don't have Discord, I don't have Reddit, Facebook, Instagram, I don't have
They
any
asked
other
for
than
it
YouTube.
18, 14, I can have
See, get Reddit and Discord.
You're already a teenager.
All right, one more.
They are.
22. I'm backtracking because I wanted us to see the 5 and -5 together. If you don't know what I was talking about with Snapchat, just disregard what I said. 1/2 times 1/4 raised to the x. So this one has a fraction in front being multiplied by it. Okay. So setting up the table. -1, 0, and 1. So I've got 1/2 times 1/4 raised to the -1, which we've said multiple times now would be 4. So this would be 1/2 times 4, which is 2. Then I've got 1/2 times 1/4 raised to the 0, which would give me 1/2. And then I've got 1/2 times 1/4 raised to the 1, which would give me what? 1/8. So notice these numbers are all pretty small. So I'm going to actually make my, just so that I can see it, okay, I'm going to make my graph a little bit bigger here. So I'm going to make that 1 and 2 here, just so that I have more room since I have 2 fractions I'm plotting. So at -1, I'm up at 2. Now, you could do this just like normal. It's just 1/2 and 1/8. They're going to kind of be crunched in there. I've spread them out a little bit so they won't be so crunched. At 0, I'm at 1/2, so I'm halfway between 0 and 1. And at 1, I'm at 1/8, so pretty close to the axis here. So, if you have a fraction being raised to a power, okay, and when I say a fraction, I mean like between 0 and 1, not like 5/4 or something like that. Being raised to a power, it is a decay function, okay, going downhill, okay. If it is a number bigger than 1, it can be a negative, but if it's bigger than 1, so not a fraction, then it's going to be going uphill, which is the ones we did yesterday, and that's a growth function, okay. So that should be your kind of easy way to check when you go back and you're checking on your test or your homework to see if you did them correctly. Obviously, within your homework, it's telling you either their growth or decay. On the test, it's not going to tell you that. In the review problems, it's probably just going to say graph the function. It's probably not going to tell you this is a growth problem or this is a decay problem. So just be aware of that. Any questions? All right, problems then are going to be 7, 11, 14, I know that's an even one, but you'll be all right. 21, 23, and 27. And that's it. So you should have plenty of time to get these done. Make sure you show your work like I did. Some people weren't doing that on their homework yesterday.